Okay, we are going to work on section 16 or 0.7, algebraic fractions. We are interested in simplifying some expressions that you typically get in functions representing business applications, profit, cost, revenue, supply, demand, things like that. The problems in this section, the simplifying of them, is the real reason why we needed to learn the factoring that we had in the last section. And so we want to be able to take expressions like this. Number 2 is really just a review of what we've already done. And all you do to simplify an algebraic fraction like this is divide every factor in the numerator and denominator by common factors that you can. So, to simplify 15a to the 4th, b to the 5th, over 30a cubed b, you want to divide 15, we're going to 15 once and into 30 twice. If I have a to the 4th, I could think of that as, if you have 1 times a to the 4th, it'd just be a to the 4th. But a to the 4th you can think of as a cubed times a, b to the 5th as b to the 4th times b, over your 2, a cubed, b. The a cubed factors are common factors, the b factors are common factors, and you get a final answer of a, b to the 4th, over 2. Now there are several ways that you could arrive at that. The way that I did it is one. Another way is if you just use your properties of exponents that we had earlier in the semester. If I have a to the 4th over a cubed, that'd be a to the 4 minus 3, using your rules for exponents, be a to the 1, and that's the a in your answer right there. If I have b to the 5th over b, likewise that would be b is b to the 1, that'd be b to the 5th, b to the 5 minus 1 would be b to the 4th, and that's where the factor of b comes from. So there's always more than one way you can think of these, and as I've often said, it doesn't matter which method you use. If you use the method correctly, you will always end up with the same answer. So a b to the 4th over 2, and that's no different from what we have been doing. The next problem that we're going to do is number 4, and this one is just a little different. This is the first one that we'll see where we need our factoring skills that we learned in section 0.6. Problem 4. We have x squared minus 6x plus 8 divided by x squared minus 16. We will often encounter fractions, algebraic fractions, or rational expressions like this in business situations. And it's very, very helpful. If I needed to evaluate this function for many different values of x, if you can simplify it, it's very helpful to do so before you start wasting a lot of time evaluating. And the way that you simplify an expression like this, let me start out by showing you what you don't do. And one of the most common mistakes that I have my college algebra students make is I will have college algebra students, they'll look at that, and they will do the following, which is wrong. I don't want to see anybody doing this. They'll look at this and they'll say, oh, x squared and x squared cancels. No, they don't. You can cancel common factors. Factors are things that you're multiplying together. But right here, x squared is not a factor. It is a term. It is being added or subtracted to the other terms there, and you never cancel terms. I think I can convince you of why that's true. If I have the fraction 5 over 10, that's obviously 1/2. But watch if I write it like this. 1 plus 4 would certainly be 5. 6 plus 4 would certainly be 10. Watch the silly, incorrect result I get if I cancel terms. The 4 and the 4, I end up saying 5/10 or 1/2 is the same thing as 1/6. Obviously not. And so we don't do that, and we don't ever do this with an algebraic expression. Never cancel terms. You can only cancel factors. And that shows us why the factoring skills that we learned in the last section are needed. I'm going to take this expression and that numerator. It's a trinomial. I can factor that into a product of 2 binomials using the FOIL method backwards. What did I multiply by itself to get x squared? An x and an x. What 2 numbers do I multiply together to get positive 8 here and here? That add together to give me negative 6x here. And the negative sign is a key. It's going to be negative 2 and negative 4. If I multiply negative 2 times negative 4, I get positive 8. My outer terms, negative 4x, plus my inner terms, negative 2x. When I multiply these together, gives me my negative 6x there. So the expression in the numerator of this fraction factors like so. The denominator can also be factored. X squared minus 16, that is a difference of two squares, is going to factor to the square root of the first term, x and x. One factor will be plus, the other will be minus. The square root of 16 will be 4 and 4. Now, what I have here is significantly different, and it enables me to cancel, because when I write x minus 2, it's a factor times the factor x minus 4. And if I cancel the x minus 4 expression, that is a factor. It's a factor in the numerator, it's a factor in the denominator. It is not a term, it's not being added to anything. And so I end up with the simplified expression x minus 2 over x plus 4. This is what you get when you simplify the original expression that was given to us. Much easier to work with and evaluate than the original expression, and that's what we're at. And that's how you do it. Let's take another example. Let's work through number 8. We're on page 48, section 0.7. Okay, I have x squared y squared minus 4x cubed y in the numerator, x squared y minus 2x squared y squared in the denominator. Again, I just want to warn you, don't you dare think about showing me anything like this when you do your work. Let me show you the incorrect way to think of this. Don't even think about saying, hey, a y squared there and a y squared there will cancel out. They will not. This y squared, yes, it's a factor, but it's part of a term being added to another factor here. Likewise with the y squared there. Don't say to yourself, hey, that x squared and that x squared would cancel. Totally incorrect result. You don't cancel terms or part of a term. So the right way to handle this problem is, look at the numerator. Is there anything that I can factor? Is there a common factor to both terms in the numerator? And I've got an x squared here and an x cubed here. I can factor an x squared out of both of those. I have a y squared and a y. I can factor a y out of both of those terms. If I take x squared y squared and divide it by what I factor out, the x squared y, that leaves me with one factor of y. I know that I factored this term correctly. If I multiply this y times what I factored out, x squared y, do I get what I started with there? Yes, I do. I have a minus sign from this. Okay. I'll have the 4. X cubed divided by x squared is x. And y divided by y cancels out. So I can factor an x squared y out of each term of the numerator. And this is what I'm left with. In the denominator, I have an x squared in each term. I have a y and a y squared here, so I can factor a y out of each term. If I have x squared y divided by x squared y, that leaves me with 1. X squared divided by x squared cancels out. I'll be left with 2y. Y squared divided by y is y. Again, if I multiply x squared y times negative 2y, I get negative 2x squared y. Now, again, significantly different. I can think of the x squared y as being a factor. I have this factor times this factor times this factor, common factors of x squared and y. My final answer is going to be y minus 4x over 1 minus 2y. That is your simplified expression for problem 8.